All right, so what happened to 7.1? 7.1 is on solving linear systems using substitution. It's probably one of the least efficient methods, so we're not going to spend a lot of time on it. And it's something that you've done in Algebra 1 and that you've done in Algebra 2. So no need to really review it. And you'll get to use some substitution anyway using in Section 7.2 and 7.3 and 7.4. So if we ask you to solve the following equations, we have two equations, two unknowns. Think about what our answer is going to look like. What are we going to get for an answer in general? We have two equations. What kind of equations are these? Standard forms of lines, right? So we've got two lines, okay? What are we trying to do when we solve them? Use the slope to, we could graph them, right? And that's another one that you do back in Algebra 1 and in Algebra 2, but we're not going to spend a lot of time graphing these. But let's think about this. One of these is a line. Another one's a line. What do lines do? They intersect, or they're parallel, or they're the same, or perpendicular. That would be intersecting again. Or they can be the same line, right? In disguise. Coincident. So we want to figure out what the solutions to these are. Most of the time, we're going to get a point, an ordered pair, unless they happen to be parallel, in which case we recognize it by having the same slope, or unless they happen to be the same line, and then they have infinite number of solutions. Okay, so how do we solve something like this? Make the bottom one negative. So multiply through the whole thing by negative. Would that help us? They actually already cancel out in this first one, right? Most of the time we have to do some work with it, but they gave us a nice problem that is going to allow us to simply add these up, and then the x's will cancel. Pause. So here we go. When I add these two up, I get 7x. Negative 3y, positive 3y goes away, which is great. That's eliminating it, and we'll get a 7. So x equals 1. Are we finished? No, that's just half of the answer, right? Plug it back in, so we're substituting. Which one do you want to substitute it into, first or second equation? To the top. So 2 times 1 minus 3y equals 7. 2 times 1 is 2. When I take it to the other side, it will be a negative 2. So if a negative 3y equals a positive 5, by taking this to the other side, then y becomes negative 5/3. That's the whole solution. So these are intersecting lines. They cross at the point 1, negative 5/3, and if you want to call that negative 1 2/3 or negative 1.6 repeating, they're all the same. Okay? Second example. Now we've got to do some work, right? So what are we going to do? Bottom by negative 2, your choice. So if I take negative 2 times this bottom one, I have to take it times both sides of the equation, and I will get a negative 2x minus 4y equals a negative 10. It's okay for you to jump over this and not pay attention to it, to add them up. That's great. 3x and a negative 2x is x. 4y and a negative 4y is 0y, and 11 and a negative 10 gets us 1. Okay? It's only half the answer, though. Plug it back in. Where are you plugging it in at? Your choice. Probably the bottom one, easier, right? So 1 plus 2y equals 5. Taking the 1 to the other side, 2y will be 4. So y will be 2. How would we check it? Plug them in. Since we put it back into the second one, we want to plug them into the first to make sure it verify that solution. 3 times 1 plus 4 times 2 is not going to get me 11. 3 and 8 is 11. We're good. Yes, Brian. Where did I get that -2? What someone suggested was it would be nice if the y's would go away. So let's take a -2 times everybody, and then the y's will eliminate. Someone else may have said, let's take it times a -3. If the -3, the x's go away, and we'll have a y to begin with. Your choice. Okay? Whichever works for you. Okay. Next one. So 3 possible solutions, right? No solution, 1 solution, or an infinite number of solutions. This one is just like the first 2 that we looked at, meaning that they cross, they intersect at a common point. In fact, here is the solution for this first one that we worked on. Okay, here's a second example, and this one will have no solutions because the lines are parallel. Okay, how can we tell that? If you look at these and we were going to eliminate something, we would want to eliminate which one? X or Y? Doesn't matter, right? If we take the top one times 2, that's going to help us eliminate the x's. What happens? 2x plus 6y equals 10. Adding them up, gone, gone. Does 1 equal, or does 0 equal 11? No. So there's no solution here. The lines are parallel. They're never going to cross. And they have the same slope. What happens with this one? Well, I'm going to take everybody times 4 in the top. Okay, I take the top times 4. I will get x minus 2y equals positive 4. X's go away, y's go away, 4's go away. That's true, so it's the same line. I just divided everybody by 4. Okay, so there's an infinite number of solutions here. These are coincident lines. Okay. How many rentals, how many sales? Anybody hear about the video or the movie called The Interview? Anybody see it? Is it good? Okay. It caused quite a stir in other parts of the world, and there were concerns about bombings of movie theaters and so forth. So Sony decided not to release it in the theaters and instead release it as a rental or as a sale through their online store. So this was a New York Times article or New York Times snippet that said the interview generated roughly 15 million in online sales and rentals during the first 4 days of availability. Sony Pictures said on Sunday, or Sony Pictures said that Sunday, Sony did not say how much of the total represented the $6 digital rentals and the $15 sales. The studio said that there were about 2 million transactions overall. Okay, we know as pre-calc students, as Algebra 2 students, how to solve something like this, right? How would we set this up? What variables do you want to use? X and Y? R and S? Rentals, sales? You choose. X and Y? Okay, let's do X and Y. And let's just make sure that we realize, Zach, you just can't win. Let's do R and S. We're gonna R and S makes more sense, right? The only concern I have about S's is sometimes they look like 5s if you're not careful. Okay, so let's use R and S. R's are our rentals. S is our sales. So the number of rentals plus the number of sales, how many did they have overall? How many transactions? 2 million. Everybody good? Okay. Now, how much were the rentals? $6. So 6 times the number of rentals plus 15 times the number of sales should be equal to 15 million. Just because it's a big number doesn't mean it has to be scary. Okay? System of equations, two unknowns, right? Okay? So what are we going to do? Yep, -6 times the top. I'll take -6 times the right side and -6 times the left side. I should get S's or R's to eliminate. So -6R minus 6S equals -12 million. Adding them up, R's go away. 9S equals 3 million. Okay, dividing by 9, how many do we get? 9 goes into 30 how many times? So 27. 3 times again, right? What are we going to get? $333,333, roughly. Okay, that's our number of sales of how many sales we had. Okay, 2 million total. How many rentals are we going to have? It's 2 million minus 333,333. Everybody okay with that? 1,666,666. We can call it 667. Do a little rounding. Okay. So you could finish that story for the New York Times writer who said Sony didn't bother to tell us how many of each. Okay. All right. Piracy is even a bigger problem. I went to Pirate Bay to see how many downloads there were during that time frame. There's this history problem that you can just figure out how much Sony lost to piracy in those 4 days. It's pretty crazy. All right, while working late to make a yearbook deadline, you and a friend make a food run to Chick-fil-A. You buy 3 regular chicken sandwiches and 2 spicy chicken sandwiches for $15.47 without tax. Your friend gets a regular and 5 spicy chicken sandwiches for $19.24. Bring them back to the yearbook club and distribute them. How much does everybody owe you for those regular and spicy chicken sandwiches? How would we set it up? R and S again. Okay, regular for R and S for spicy. So first time you actually went, you and a friend went, you bought 3 regular and 2 spicy, and they were $15.47. Okay, person who went on the run with you bought 1 regular and 5 spicy for $19.24, not including tax. That is a huge jump. Looks like the spicy's maybe, yeah. All right, so how are we going to solve this? Okay, we can multiply the top by 2.5. Okay, -2.5. We could make it tough on ourselves. We could take the bottom times -3. Your choice. You can make this an Olympic math event, or you can make it an easier one. So 3R, -3R minus 15S, and break out the calculators here. 1924 times a -3. Point what? 17? Okay. 72. Thank you. All right, so we're almost there. Okay. Now we're going to add these two together. So 3r and negative 3r gone. 2s and negative 15s. And 1547 and a negative 5772. How much? 4225 divided by 13. 3.25. $3.25 for a spicy chicken sandwich. Okay. 3 of those regulars plus 2 of the $3.25 spicy chicken sandwiches should be equal to $15.47. So we're going to say 3 R's plus 6.5 is 1547. Taking the 6.5 away, what do we get? Okay, thank you. What do we get? Mental math isn't very good with long decimals, is it? 803. Is that right? Check your calculators. You guys have a calculator in front of you. 897. Dividing it out. 299. So 299 for a regular chicken sandwich, 325 for a spicy one. 26 cents difference for all that spice. Okay. All right, there's your assignment.